But for now, let's just review the basic parent functions. So next, we're going to have a rational function, 1 over x. So what's the parent shape for this function? For this particular function, you need to realize that there is a horizontal asymptote known as y is equal to 0, and it's also a vertical asymptote, which is x is equal to 0. I'll talk about how to find that later, but for now, just know that it exists. This graph looks like this. It's symmetric about the origin. Here's the origin. As you can see, this side is a reflection of that side across this point. Now, whenever you have a rational function, you need to remove the vertical asymptote from the domain. Notice that x could be anything except 0. There's no yellow line on this vertical asymptote. So you have to remove the vertical asymptote from a domain. So the domain is going to be negative infinity to 0, union 0 to infinity. So this means that x could be anything except 0. Now, whenever you have a problem with a horizontal asymptote like this one, where there's only one vertical asymptote, notice that the function can never have a y value of 0. It doesn't touch the horizontal line. So you need to remove the horizontal asymptote from the range. So this is also going to be negative infinity to 0, union 0 to infinity. Here's another rational function, 1 over x squared. So this graph is similar to the last graph, but there are some differences. There's still going to be a vertical asymptote at x equals 0. And we're still going to have a horizontal asymptote, which is y is equal to 0. Now, because the function is squared, it can only have positive values, which means the function has to be above 0. It can't be negative. So the right side is going to look the same. The left side, it won't be here. Instead, it's going to flip over the x-axis. It's going to be here. So this particular function is symmetric about the y-axis. As you can see, the right side looks like a mirror image of the left side. So it's a reflection across the y-axis. Now, what is the domain of this function? As we can see, the lowest x value is negative infinity, and the highest is infinity. But there's no point on a vertical asymptote. So once again, we need to remove the vertical asymptote from the domain. So x cannot be 0. So it's going to be negative infinity to 0, union is 0 to infinity. Now, what about the range? Notice that the lowest y value is 0, but the highest is positive infinity. And because the horizontal asymptote is y equals 0, the function never touches the horizontal asymptote. So it's greater than 0, but not equal to 0. There's no value of x that you can plug in that will give you a value of y. You can get very close to 0, but you will never reach a y value of 0. If you plug in 1 into x, y is going to be 1. If you increase it to, let's say, 100, y is going to be 0.0001. If you increase to 1,000, y is going to be 0.000001. It's going to get closer and closer to 0, but it never actually touches 0. So the range is going to be from 0 to infinity, but it does not include 0 since that's a horizontal asymptote. So we have to use a parentheses.